FastMCP employs a declarative decorator-based metadata system to customize prompt components, enabling explicit parameterization of functional attributes through standalone annotations. This architectural pattern decouples component definition from runtime registration, allowing developers to specify identifiers and categorical tags directly within the function decoration layer. We're about to examine how the @prompt decorator accepts a name parameter to override the default function name-derived identifier and a tags dictionary to associate semantic metadata, while maintaining the same signature-to-template transformation behavior as undecorated prompt functions. The implementation will reveal how these parameters integrate with the broader discovery mechanism without requiring explicit server instance coupling. From FastMCP prompts import prompt. @prompt name equals explain concept. Tags equals education. Def explain topic. SDR. Generate an explanation prompt. Return F. Explain topic using clear examples and analogies. This code demonstrates how to customize prompt metadata using the @prompt decorator in FastMCP. The decorator accepts parameters like name and tags to explicitly define the prompt's identifier and categorization, overriding the default behavior of using the function name. This approach provides flexibility in naming conventions and organizational tagging, which is particularly useful in larger systems where prompts need to be grouped or filtered by tags. The explain function shows a practical example where the prompt is named explain concept and tagged with education. This metadata customization allows for better discoverability and management of prompts within the FastMCP ecosystem. The trade-off here is between explicit control and convention-based simplicity. While custom names and tags offer precision, they require additional configuration compared to relying on function names and implicit categorization. This pattern is ideal for scenarios where prompts need to be tightly organized, or when integrating with systems that rely on specific naming conventions. Let's break it down line by line. From FastMCP prompts import prompt. Imports the prompt object from the FastMCP prompts module, making it available for use in the current scope. This provides access to FastMCP's prompt handling functionality, though the specific capabilities aren't demonstrated in this line. @prompt name equals explain concept. Tags equals education. Def explain topic. SDR. Generate an explanation prompt. Defines a function named explain that takes a string parameter topic and returns a string. The function is decorated with @prompt, which sets the explicit tool name to explain concept and tags it with education. If no name is provided, the framework uses the function name as the tool name. Return F. Explain topic using clear examples and analogies. Returns a formatted string that instructs to explain a given topic using clear examples and analogies. The topic variable is interpolated into the string at runtime. The @prompt decorator in FastMCP enables explicit control over prompt metadata through a declarative approach, decoupling component definition from runtime registration. By specifying name and tags parameters, developers override default conventions, like function name-derived identifiers, while maintaining the same signature-to-template behavior. This pattern balances flexibility with structure, allowing precise organization in larger systems where discoverability and categorization matter. The trade-off is clear. Explicit metadata requires upfront configuration, but pays off in maintainability and integration with systems relying on specific naming conventions. The explain function example ties it together, showing how a simple prompt gains semantic context through tags like education and a custom name, all without tight coupling to server instances. This metadata-driven design keeps prompts modular and adaptable, aligning with FastMCP's broader goal of scalable, discoverable prompt management.
The @prompt decorator whispers functions into existence, then hides them until the server sneezes.